Given f of x equals 4 to the power of x, label which graph best represents f of x. G of x equals f of negative x, h of x equals negative f of negative x, and j of x equals negative f of x. All right, so first thing we need to identify is which one of these graphs is f, or of f, rather, 4 to the power of x. Now remember, this is exponential, so it's going to look like a plane taking off without any transformations. The one that looks like a plane taking off would be A. The way to check is it should always hit the point 0, 1, because if you put in an x to the power of 0, anything to the power of 0 is always equal to 1. So x value of 0 has a y value of 1, so we should have this point 0, 1. And then 4 to the first, if you put x equals 1 in, 4 to the first is the same thing as 4, so you should have the point 1, comma 4. That's how I'm checking this right here. So if I go over 1, up 1, 2, 3, and 1, 2, 3, it doesn't even appear this graph is totally right. This should be a 3 here to make it accurate. That should be a 3. So this would be f to the power of, 3 to the power of x represents f there. Now, as we go through the rest of these, we start looking at transformations. For g, you have a negative on the inside. So according to the first rule of transformations, HIVO, horizontals inside, verticals outside. And the second rule, if you remember, is that inside lies while outside tells the truth. Outside tells the truth. There you go. So this is an inside reflection. And what that means is anything on the right will go left, anything that's left will go right. So if you look at this point, what we should be looking for is instead of having 0, 1, anything on the left should go right, and right should go left. So it's a reflection of the x value. So the 0, 1 won't change. It should be 0, 1, but instead of 1, comma 4, we would have negative 1, comma 4, which in this case, since we said this should be a 3, I'm going to change it to a 3. So I'll scratch this and make this a 3 there. So I should be looking for negative 1, 3, and 0, 1. Let's see if this is it. If you go here, I have 0, 1. And if I go left 1, up 3, 1, 2, 3, I do have this graph. This graph B is g of x. This one over here was f of x. A was f of x. B would be g of x then. Next graph, 8 negative of negative x. So that means both the y and the x are intervals, are negatives, I'm sorry. So there's reflection both up and down and left and right. So if you take your 2 points, what you should have, if you reflect both the y and the x, 0 won't change. It'll still be 0, but the 1 will become negative. This is saying make negative the y and the x. And so this one, rather, you got to go from here. This 1, comma 3 would become negative 1, comma negative 3. And so that's what I'd be looking for here. Is this value 0, 1? And is this negative 1, negative 3? Answer is it's not. So it's not that graph. It would actually be this one. That would be 0, negative 1, and then negative 1, negative 1, 2, and 3. It's here. So this would refer to D. And so D is the graph h of x. That means C must be j of x. Let's make sure it is. Let's test it real quick. We think that's going to be j of x. It just says make the y's negative. So again, I take the original points. But instead of 0, 1, it should be 0, negative 1, which it does have that point. And then instead of 1, 3, it should be 1, comma, negative 3. So if I go right 1, then if I go down 3, I get that point. So this is correct. This is F, G, J, and H.